There's big data, and then there's the biggest data. I'm Tonya Hall for ZDNet and Tech Republic, and joining me is Vijay Raghavan. He is Executive Vice President and Chief Technology Officer for LexisNexis Risk Solutions. Welcome, Vijay.
Thank you. Glad to be here.
What does LexisNexis Risk Solutions do?
So the way I like to describe that in one sentence is we help our customers reduce the risk of doing business with their customers. And the way we do that is we collect large amounts of data, public records data, contributed data from our customers, and we put all that together. It's a classic big data problem. But what's different about us relative to, let's say, credit bureaus, et cetera, is that we help our customers calculate the risk of people who are underserved or underbanked, people that don't necessarily fit onto the grid. And so using these alternative data sets, we're able to help our customers calculate risk in a much more robust way. And the impressive thing about that is that it helps our customers, of course, and it helps consumers because on one of our verticals is insurance. Consumers can get a better deal on insurance. Customers can get better solutions in terms of fraud, those kinds of things. So those are just a couple of examples in terms of how LexisNexis Solutions serves our markets.
You say that machine learning can help us make decisions, but it cannot replace human intelligence. We can't take an autopilot analytical approach when making decisions. What is the right balance then between analytics and intuition?
Yeah, so in order to answer that, before getting right into the technology, let me explain a little bit further about what LexisNexis Solutions does, because that context is important when we talk about the balance between human involvement and machine involvement. So when you look at some of the things that we do for our customers, it's really important that we are fair and ethical to the consumer, in addition to providing a good solution for the customer, right? So when I talk about insurance, it's really important that we give our customers the ability to make fine-grained decisions in terms of how to give the right, calculate the right kind of premium for a consumer. It's also important that the average consumer is able to get a better deal on insurance as a function of our solutions. The same thing holds true of when I was talking about the underbanked or underserved markets. It's really important that the consumer is able to get a good deal on a mortgage rate and is not suffering from bias on account of a model that's been calculated or implemented the wrong way. So you get the picture. So when you look at all these, healthcare is another example. We create a social graph, in effect, in healthcare by connecting patients with pharmacists to prescriptions and claims and so on. And then we construct models and attributes out of that to be able to then provide the right kind of solution to our healthcare customers. So when you look at that context, you probably get an inkling of why it's so important for us to get machine learning done the right way, which means it can't just be logical. It has to be ethical. It has to be bias-free. So it's not quite the same thing as looking at a bunch of cats on the internet and trying to figure out whether this is also a cat or not, because you don't need to be particularly fair or ethical about that. But when it comes to impacting a consumer's livelihood or consumer's wallet, it's really, really important that we intersperse machine learning or deep learning techniques with human involvement, which is the judgment of the modeler in terms of identifying what is the right kind of technique to use. Is the data set, in fact, accurate? Is the data set representative? And assuming it's a supervised kind of model where you're using a training set, is that a good training set? Is it a complete training set? Or are you introducing bias into the model either because you're using the wrong data or incomplete data or very highly selective data or maybe the wrong technique? So those are just some examples of how the human involvement in machine learning is vital.
You embraced big data and implemented a data platform before most companies knew they had a big data problem. What was that problem exactly?
Yeah, that's an interesting question, because back in 2004, 2003, or even earlier, we were in the business of collecting lots of data on small businesses and consumers in order to solve these kinds of problems that I was talking about. And in collecting the data, we had so much data that we essentially had a big data problem long before big data was even a thing. There were very few companies, and these days, big data, in fact, more than starting in the late aughts, I guess, 2008 or so, Hadoop and all these other platforms came into being. But prior to that, you only had the conventional transactional databases like Oracle and SQL Server, and those don't really cut it when it comes to handling big data. And so we had a classic, what's called an n-squared problem, because when we collect data from 10,000 different sources, and I literally mean 10,000 different data sources, and we're talking about billions upon billions of records across those 10,000 data sources, what we needed to do was to link all the data very precisely. Why is that important? Because if I need to establish that these 387 records across these thousands of data sources belong to Tonya Hall, I'd better get that right. It can't be 80% accurate. It can't be 90% accurate. We actually get it to 99.9937% precision, as we call it. And that's important because once we get to that degree of precision, then we can calculate the right kinds of attributes and models about you. But if you can't get that right, then there's no way we can calculate an accurate attribute or a model about you. So that's why big data is almost a precursor. I guess it's a two-part answer to your question. The first part of the answer is we recognized that we had a big data problem long before big data was a thing. And we created this platform called the HPCC, the High Performance Computing Cluster, which we actually open sourced about 7 years ago because it actually fit our needs very well and did a great job. But the second part of the answer is, in order to be able to construct a good machine learning model, or any kind of model for that matter, you need that kind of accuracy of the comprehensiveness of data and the accuracy of linking of the data, without which you don't have a foundation to be able to create good models.
What machine learning problem exists today that, when solved, will contribute to the next breakthrough or milestones?
Yeah, so when you look at the kinds of machine learning problems we solve today, I really classify it into two kinds of things. One is, of course, how machine learning can help us build models faster and more accurately, and help us discover features with greater ease, right? So that's what we do today. As I mentioned, we don't really use machine learning in the context of completely automating model building because of the reasons that I mentioned in the past, which is the machine may come up with answers that are perfectly logical, but not necessarily right for the consumer. Or just as equally, it will come up with models that are, we often think that humans can be accused of bias, but machines can inadvertently come up with their own biases that we don't even know about unless we check after them, right? Check upon them. So in terms of advancement, or the next stage of advancement, when we talk about deep learning, this is where we get into the transparency conundrum, by which I mean the advantage of a deep learning model is that it can potentially look at layers upon layers of features and try to figure out from, when it's trying to calculate whether it's a facial recognition or voice recognition or something like that, it's looking at first lines and then patterns and then facial features and then a full face, right? But it doesn't necessarily calculate that in a deterministic way. In other words, you can't really figure out how it came to that answer, how it came by that answer. Now, that may be okay in certain situations, like in the context of an autonomous car or something like that. Maybe you don't always need to know, although it's in that particular example, you might need to know if there's an accident. It certainly is very important to figure out the transparency of the model when you talk about the Fair Credit Reporting Act and the kinds of things that we have to abide by from a regulatory standpoint. So really, the next stage of deep learning, I think, is going to be combining the advantages of deep learning. Clearly, there are advantages in terms of how it can offer more autonomous and more automated model building, or better and faster model building, but coupled with the transparency that we seek and that our customers and our regulators seek, so that we can get the best of both worlds.
What should individual consumers know about data collection and application to help them protect their privacy and security, or has the issue become too large and complex for individual efforts to matter?
No, I don't know that it's become too large and too complex. I think there's multiple aspects to how a consumer should think about it. One is, of course, to be conscious of the fact that when you share your data with a large organization explicitly, like with a Facebook or a Google or whoever, you're trading the convenience of the usage of the platform with the data that you give with them. That's just a fact. So it's just, it shouldn't be, I mean, the only way to avoid that is to say, no, I'm not going to get onto Facebook and share my data. So that's one aspect. But there's a different aspect when it comes to companies like us, which are not social media platforms per se, because what we do is to help customers, but we help consumers as well. And that's something that we don't necessarily go, stand with a bullhorn and announce to the public, but it's very important for consumers to realize about how much good a company like us does for society, simply because if it weren't for companies like us, a lot of consumers would not be getting good deals, or would not be able to get mortgages, or would not. In other words, going back to the point that I made early on in this discussion, there are plenty of people that don't have access to credit or the right kinds of deals simply because they're not on the grid. That could be because they're new immigrants to the country. It could be because they've just graduated from high school and have become adults and don't have much of credit history. It could be because they don't like to use credit, right? Those are the kinds of people that we try to fill the gaps on when it comes to our customers and consumers. So they get a better deal in general, and they get back on the grid. And I mentioned that because sometimes big data is seen as a not necessarily a good thing, and companies that are of this ilk are seen as big data brokers or collectors of data. What we actually do is to benefit our customers and benefit society at large because of what we do.
Vijay Raghavan, Executive Vice President and Chief Technology Officer, LexisNexis Risk Solutions. If somebody wants to find you, maybe they want to understand more about your work, or maybe they have questions about big data, how can they do that?
So they can find me on LinkedIn, just searching for Vijay Raghavan at LexisNexis Risk Solutions. They can certainly send me an email directly at vijay.raghavan, vijay.raghavan at lexisnexisrisk.com. Those are a couple of ways in which they can contact me.
Thanks again, Vijay. And if somebody wants to find me and more of my interviews, you can do that right here on ZDNet or Tech Republic, or maybe go to my website, tonyahall.net. I've got links to all my social sites. Thanks for watching.